Graph a quadratic function. The graph shows below is a graph of simplest quadratic function, which is y is equal to x to the power of 2. The graph is called parabola. Let's take a look at some of the points here. If I let x equal to 0, y would be equal to 0 squared or 0. So we know my graph going to pass us through the origin, which is right here, 0, 0. If I let x equal to plus or minus 1, because this is a square, y would be equal to either 1 square or minus 1 square, which results into 1. So the other 2 points I can find is negative 1 and 1, which is right here, and 1 and 1, which is right here. So you notice that you get this point to the other side of this y-axis, same distance. The next point happened to be also the same distance from this y-axis. If I let x be equal to plus or minus 2, then y would be equal to either 2 squared or minus 2 squared, which results into 4. So if x is equal to 2, y is equal to 4. If x is equal to minus 2, y is equal to 4. You notice that we get 2 points, same equal distance, right to the right of this y-axis. So now we have enough points to graph our parabola. My parabola shapes like this, passes through these points that I just find an origin. And the lowest point of this graph is right here. This is called vertex. The point 0, 0, the lowest point on the curve, is called vertex of the parabola. The vertical line through the vertex is called axis of symmetry. So the line that go right into the vertex, that would be a line of symmetry. That's the line of symmetry. Or simply the axis. The parabola here, that would be simply the axis of this parabola right there. Now the equation of this line is x is equal to 0. Remember, the equation of the vertical line is a form of x is equal to k. K would be the point that passes through the x-axis. So the equation of the axis of symmetry for this parabola would be x is equal to 0. Not 0 only, just x is equal to 0, because the equation has to be written in the form of x or y. So this would be x is equal to 0. That's the equation of this line here, which is called axis of symmetry. You notice that a parabola is symmetric above its x-axis. That is, if the graph were folded along the axis, if I fold this graph along the y-axis, the two portions of the curve would be coincide. So this point would be right on top of this point here would be right on this point. So that's why we call this axis of symmetry. So this is the shape of y is equal to x to the power of 2, which is a parabola. Quadratic function, a function that can be written in this form: ax squared plus bx plus c. For real number a, b, and c, and a cannot be equal to 0, because if a is equal to 0, this term is going to be gone. It's not going to be a second order equation anymore. It would be a first order equation, which is a line. So if that's true, if you have this form here, then this would be a quadratic function and looks like a parabola. The simplest form of parabola that we just graphed looks like y is equal to x squared, when a is equal to 1, b was 0, c was 0 in that example we just did. So f of x or y is equal to x squared is the simplest form of parabola. The graph of any quadratic function is a parabola with a vertical axis. We're going to take a look at more examples. Let's say we want to graph f of x or y is equal to x to the power of 2 plus 3. Now if I make a chart here and I substitute some numbers, we can easily find these points and try to find the shape of this parabola. But you can also note that if I remember the shape of my parabola, where it looked like y is equal to x squared. If y is equal to x squared, my parabola is going to pass through the origin and it's going to pass through point 1, 1 right here and negative 1 and 1. So this parabola would look like that. Would be same shape as what you see up there. So the equation for this parabola, the simplest form that we did earlier, is y is equal to x squared. When I shift this parabola 3 units up, looks like this equation changed to y is equal to x squared. Then this number would be different number. Would be, in this case, because we're shifting this 3 units up, that would be plus 3. So if every time I add a number, I'm shifting that parabola that many units up. If this were minus, you can guess that would shift the whole thing down that many units. So that would be a good method to remember how the parabola shifts up or down. So instead of finding all these numbers and find the vertex is at 0.03, you could say, all right, I have a parabola that vertex is at the origin. If I shift it up 3 units, now the vertex would be 0.3. Now, the range and domain would be the value of x. For the domain, you look at the value of x to see if there's any restrictions. This parabola here, both of these parabolas, would gradually cover all the numbers on the x-axis. There's no restrictions here. So the domain would be all real numbers, all the way from negative infinity to positive infinity. But as you see, the range for this, the range would be value of y. The range has to be above 0.3 on the y-axis. So when you talk about the range, you're looking at the values of y. So all the numbers from 3 and up, or you can write in interval notation, brackets 3 because 3 is included, all the way to infinity would be the range. So we're going to find the range for y is equal to x squared would be all the number from 0 all the way to the infinity. So the range for this one, the range for y is equal to x squared would be all the numbers from 0, because we're shifting the graph down, right at the origin, comma infinity. But if I shift this up, the range would be from 3 up. But the domain would be the same for both of them. So as the axis of symmetry, because the axis of symmetry is a line that goes through the vertex, which would be the same, would be x is equal to 0. So vertical shift of the parabola, the graph of a f of x equal to x squared plus k is a parabola. The graph has the same shape as the graph of f of x equal to x to the power of 2. The parabola is shifted k units up if k is positive, and absolute value of k units down if its k is negative. The vertex would be at 0k. That's exactly what we looked at earlier. So if you look at the parabolas that's shifting to the right and left, is different from shifting up or down. So here, where the graph shifts up or down, like you saw here, the number add outside this function. However, if I add the number inside x, like in this example here, You see the number 2 is adding inside the function. This is where you see the graph would shift to the right or left. Now, if I were going to graph this, I can go ahead and come up with some points here. If x is equal to 0, for instance, if x is equal to 0, if I substitute 0 here, f of x or y would be equal to 0 plus 2 squared would be equal to 4. So this is how you can see my parabola going to pass us through this point here, this point right there. So 0 and 2. So 0 and 2 would be right there. So if x is equal to 0, y is equal to 4. I'm sorry, 0 and 4. If x is equal to 0, y is equal to 4, which is right there. Now, if x is equal to negative 2, you see if x is equal to negative 2, negative 2 plus 2 is 0. This is where you can find your x-intercepts. So you see this parabola looks like it's shifting to the left. It shifts to the left. So this was the equation y is equal to x squared. Now when it shifts to the left, looks like is y is equal to, I'm going to write this as x minus 2 squared. The reason I'm writing it to look like that is because that's why here we have plus. This minus is part of the formula. So we're really moving 2 units to the left. So if I were going to shift this parabola to the right 2 units, look like that, the equation of that would be y is equal to x squared minus 2. This minus is part of the formula. 2 means how are you shifting right or left. Plus 2 because you're shifting it 2 units to the right. Here's minus 2 because shifting it to the left. It's a little confusing because it looks like you're shifting opposite of what it appears to be. Here you have x plus 2 and shifting to the left. X minus 2, better correct this. This would be look like that. Okay, I'll confuse you now. So this one would be shifting to the right 2 units. This minus is part of the formula. And this would be shifting to the left 2 units because it's minus 2. Again, it looks like that we should shift to the right here because it's x plus 2. But this is really is x minus 2 squared. So remember that if it's plus, you shift to the left. If it's minus, shift to the right. That's one way to remember it. So that's how you can use this shifting method for horizontal shift. For the vertical would be the number 2 added outside this, like I had earlier by mistake. If the number added outside x, that would be the shifting up or down. If this number added inside x would shift to the right or left. So horizontal shift of the parabola, the graph of f of x is equal to x minus h squared is a parabola. Notice that this is a general equation of the parabola, and this minus is part of the formula. The graph has the same shape as the graph of f of x equal to x to the power of 2. The parabola is shifted h units to the right if h is positive, and absolute value of h units to the left if h is negative. The vertex of the parabola is h and 0. So you look at the value of h. So in this case, my h is minus 2. I'm shifting it 2 units to the left. Here my h is plus 2. I'm shifting 2 units to the right. Take a look at this example. Graph of f of x is equal to x minus 2 squared plus 1. So if you remember, the graph of the parabola that opened in the origin would be right here. Looks like this parabola from the origin, it's shifting both ways. So if I'm going to, let me go ahead and locate the graph of the parabola where it's not shifted, would be right there. So this would be a parabola that open on the origin and go to these points. This would be the graph of y is equal to x squared. Now, y is equal to x squared if shifting 2 units up, because this number here adding outside the function there. So I'm sorry, 1 unit up. So you from here you see how you moved 1 unit up. From here you shift 1 unit up, and here you have -2. This 2 means you shifting 2 units to the right. Okay, so you're shifting 2 units to the right and 1 unit up. So from the origin, I'm shifting 1 unit up, 2 units to the right, and I copy that same shape here. So this would be the graph of this. Simple as that. So the graph of f of x is equal to x minus h squared plus k. This would be a general equation of the parabola. Notice that this minus is part of the formula. So in this case, your h is how far you shift right or left. K would be how far you shift up or down. Okay? So in this case, you're moving 1 unit up, 2 units to the right, and that would be the location of your vertex there, h and k. Your vertex would be 2 and 1. The graph has the same shape as the graph of y is equal to x squared, which is right here. The vertex of the parabola would be now this point here, not this point, is h and k. H and k, that would be position of the vertex. And the axis is the vertical line that going through the vertex. So it would be x equal to h, which is in this case 2. So this is the axis of symmetry. Now you notice that the range for this one is above 1. So you write bracket 1 to infinity, whereas the range for the original one was 0 to infinity. And the domain would be all real number for both, because this is going to gradually get increases to both sides and cover all the numbers on the x-axis. So we didn't really need this table to graph this. I just looked at the graph of the original y is equal to x squared, and I shift that 1 unit up, 2 units to the right, and there is my parabola. You can confirm that using this chart.